In this video, I'm going to show you how to model basic situations using functions of one variable. So this says a square is inscribed in a circle. Write the area of the square as a function of the radius of the circle. So first of all, we're trying to write the area of the square, but we want it in terms of the radius of the circle here. So we need to put some variables in here. So let's say that the square has side length x, and because this is inscribed, we know that that's the radius. So I've got two variables here. The area of the square we know is just x squared. So I could write the area of the square as a function of the side, which you know is pretty obvious. A of x equals x squared. But that's not what I want. I want it as a function of this radius here. So what we want to do is replace that x with an expression involving the radius. So let's see if we can do that. I'm going to maybe note that I can make a right triangle here. And because this is a square, that means that that bisects this side. So each of these are x over 2. And again, because it's a square, that implies that's x over 2. Okay, so now there are a couple ways of getting at the relationship between r and the sides of this triangle. Let's just use the Pythagorean Theorem. So we know that x over 2 squared plus x over 2 squared should equal r squared. And that tells me that x squared over 4 plus x squared over 4 equals r squared. And that tells me that x squared over 2, right? Because a fourth x squared plus a fourth x squared is x squared over 2. That equals r squared. Multiplying by 2 gives me x squared equals 2r squared. And that means that I can replace, I mean, we could solve for x, but we're basically where we want to be, because now I know that x squared is equal to 2r squared. And if you look above, we can replace the x squared with 2r squared. So now I can write that the area is x squared, but that can be replaced with 2r squared. And now I can use function notation and say a of r. So the area of the square as a function of the radius of that circle that it's inscribed in is 2r squared. Okay, here I'm given a rectangular prism with a square base. It says that the volume of the rectangular prism is 400 cubic meters. Find a function in one variable that models the surface area of the prism. Okay, so we need to put some variables here. We know that the square, it has a square base, so let's call that side x and that x, since it's a square. The height must be a different variable, so we need to put an h there. Okay, so let's go to what we're asked. It says find a function in one variable, that's key, that models the surface area of the prism. So to start, let's just write down what the surface area of this prism would be. So let's say S is the symbol I'm using for surface area. And I know that the surface area is equal to the bottom area plus the top. So each of those has area x squared. So it's 2x squared. Okay, so that's the top and bottom. Plus the area of the sides. And there are 4 sides, and each side has area x times h, because it's just 4 rectangles. So I'm going to write xh, and that's a times 4. Sorry, plus 4xh. And again, that is the sides. Okay, so that's the surface area. The problem is it's in terms of 2 variables, not 1 variable. What I'd like to do is replace that h if I can. If I can replace this h with an expression involving x, then I might be able to write it in terms of 1 variable. So to do that, we go back to the constraint or the info they gave us in terms of the volume. They told us that the volume of this prism has to be 400 cubic meters. So recall that the volume the volume of this prism is the area of the base times the height. So it's x squared times h, and that has to be 400 according to this problem. But that implies that if you divide both sides by x squared, that implies that the height can be expressed as 400 divided by x squared. And that is what I'm going to replace this h up here with. So this right here is, oops, I need to erase it. I want to substitute that with 400 over x squared. And then I will have the surface area in terms of one variable, namely the length of the square at the bottom, the square base. Okay, so this is going to be s equals, so 2x squared stays the same, plus 4x, so my h now becomes 400 over x squared. Okay, and you could stop here if you want, and you could now use function notation if you'd like, because we do have it in terms of one variable. So I could say s of x equals, and then, you know, usually when it comes time to do calculus, which you'll ultimately do with this type of thing, or plug it into your calculator, you might want to clean it up a little bit. So we could say s of x equals 2x squared. Now if I multiply that 4 times the 400, I get 1600. And then the x divided by x squared is going to cancel one of the x's in the bottom. And so I've got that. So now I've written the surface area of this particular rectangular prism in terms of one variable. So I use my basic formula for surface area, and then I utilize the constraint over here involving the volume, and that allowed me to replace the height with an expression involving x, and now I've got it. So in this video, we're kind of breaking down a few of the basic steps that we're going to be using to do what's called optimization, and then you'll do that again in calculus. So it's an important skill, but in any case, we'll stop here. There's your function, and we've modeled it.